Asia, having some very interesting challenges and projects that we see in our customers as well as in our partners. But that's it. I'm going to be talking today about a specific story that I had the pleasure to actually be heavily involved in as a key architect. Right? It was actually a project in Thailand, and while they sorted out, it's actually a project that happened in Thailand, but it spanned actually 6 different countries, right, in Southeast Asia. So that includes places like Vietnam, Myanmar, Philippines, and so on and so forth, right? Cambodia, and so on, right? And this particular project was with a company called Ascend Money. Question: how many of you all know Ascend Money? Apart from the guy, okay, by the way, one of the tech leads of that project, from Ascend Money is at least seated there, right? After that, I actually hired him into my team for a while, before he joined Google, right? But anyway, you all know True, the telco in Thailand? Yeah? Okay, so anyway, True is one of the biggest telcos in Thailand, right? Probably, now it's probably number 1. Or number 2 behind AIS. They instituted an e-wallet system, right? More to store for prepaid credits. Yeah, this was many years ago, like a long time ago, right? So basically, you top up your wallet, you can use it to draw down for your prepaid subscriptions for your mobile phone, right? They wanted to expand their use case, right? And they actually did it in Thailand first. Soon I could use that particular wallet to make purchases at McDonald's, at 7-Eleven, and so on and so forth, right? Which became a very interesting use case for an e-wallet system. Yeah. When this project happened about, I want to say probably about 4 years ago, 4 or 5 years ago, right? And what they wanted to do was to actually expand this capability to be the leading e-payments provider across Southeast Asia, right? Excluding yeah. They wanted to expand Vietnam, Cambodia, Indonesia. And you know, all these markets have providers, right? And there's also a lot of challenges from a regulatory point of view, right? On going into a market as a Thai company, right? But they wanted to expand that as a business. What they did was to acquire a bunch of companies within those countries that already had e-payment licenses. Yeah, and they wanted to integrate them together, right? So that you maximize efficiency, resources, and stuff like that. Yeah. One of the key use cases for this was actually remittance. Right? You mentioned the foreign workers in Thailand. They have their home bases in places like Myanmar and other countries, right? How do they send money back traditionally? They have to actually get a courier of some sort or use some expensive wire transfer that is going to charge that person's family a huge amount of dollars, right? Or a huge percentage kind of commission. Yeah. With this particular solution in place, right? People could actually remit money to their families at a much lower cost, like literally like a lot lower, right? Almost zero cost actually. And with that, you were actually able to use this within their own countries to make purchases as well through the e-wallet system, right? And actually this was really important because it addressed a huge population of what we call the unbanked and the underbanked population in Southeast Asia, right? People who literally did not have a mobile phone, people who did not have a bank account, right? They now have access to e-payment capabilities, right? And how do you do this? If you don't have a phone, how do you do this, right? They actually had kiosks in the so-called mom and pop shops in their villages, right? You know, the one provision shop that will have certain facilities, right? They actually have these kiosks in those villages and people can transact via that kiosk, right? But there was, of course, a lot of challenges, right? When they acquired all these companies had their own way of doing their application development, which was a big challenge, right? Some of the entities, for example, focus completely on .NET development. Others focus on monolithic Java development, amongst others, right? There was no easy way for people to reuse the work done in one country in another, which was, of course, cause for lack of optimization and efficiency. Yeah. Let me just move the slide one bit. One of the things that they actually did was to try to standardize a platform for all these companies and all these various entities to start and try to develop modules together, right? They had to cater for not just cloud native capabilities. They wanted to go there, but they were not everyone was ready, right? So they actually used a lot of monolithic applications as well, right? Or stateful applications they needed to be able to support that, right? Existing applications as well as new applications. And once again, they wanted to maximize code reuse as much as possible. That way, from a go-to-market perspective, they're going to be a lot faster than their competitors. Yeah, and that's important. When I want to release a feature, I need to release it fast, right? Because if not, my competitor is going to release it for me. Or if my competitor releases a feature, I need to have the equivalent capability released in the market. Yeah, and of course, after a lot of evaluation, they actually used Kubernetes as the platform and specifically OpenShift as the platform to standardize all application development and deployment across the 6 countries, right? Which was actually what you would think would be a tremendous task, right? It's not easy, and this was like 4 years ago. It's not so straightforward. We actually rolled it out in about 6 to 8 weeks from a platform perspective, which was amazing, right? So we used capabilities like Ansible and stuff like that to actually automate the deployment after we had a template made out of Thailand, and then we replicated that deployment across the other entities, right? Which was actually kind of interesting. If you think about the deployments that were done, they actually utilized a lot of Google Cloud services as well, right? To actually then run certain services that connected back to the underlying applications running on the OpenShift environment, which was actually a fairly good hybrid cloud deployment as well. One of the reasons why we chose OpenShift, and a big reason why we chose OpenShift in that particular environment, was because of its ability to handle both greenfield cloud native development, which they were moving towards, right? So you think about all your microservices deployments or applications, as well as modern types work that they were doing, and also the legacy apps that we have. Yeah, so you could easily have a shared repository, deploy applications as much as possible with code reuse, right? And that basically enabled a lot of things for many different countries, right? Once again, we think about the competitiveness, collaboration between teams, which was a big challenge as well, because we literally wrote in different languages, right? And having to standardize that was a tremendous task as well. But ultimately, they did manage to reduce a lot of time to market to release features to the platform, to the various apps running in individual countries very, very effectively. The other thing is that they needed a certified platform from a security perspective to address compliance and regulations of each individual country, right? And they actually achieved that, right? So if you think about as of 2021, right, and this is based on their financial report for 2021, which was released last year, they had over 50 million users on the platform, right? Which is a tremendous success in my opinion. 88,000 different agent networks across various entities in Southeast Asia. It's a fantastic story, actually, on how Kubernetes actually enabled economies, like even people who don't have bank accounts, who don't have mobile phones, to actually get access to these services, right? I think to me that's a huge community-driven of something that addresses the community, right? Especially people who are without these facilities. Just want to share the story with you. Once again, if you guys have any questions, right, one of my ex-colleagues here was one of the key engineers at that point in time for this particular project. So, if you want to ask any specific technical questions, right, feel free to as well. Just moving on a little bit, and I don't intend to do a product pitch or what have you today, right? That's not the intention. But I also wanted to open the floor to you guys. I didn't know what profile you guys are from, mixed community-based sessions. But today you think about the container stack, right? Kubernetes is one component in the container stack. There's a lot of other different components that's needed to actually run applications that are production grade, right? Everything from the underlying operating system, the container runtimes, things like networking, storage, application lifecycle development, automation, deployment, so on and so forth. And even in this particular case, we actually worked with F5, right? And they provided the load balancers for the set, right? So they were part of the story as well. But these are typical challenges that any customer or anyone deploying container platform will face, right? Especially today when you talk about security, there are many different points where this needs to be taken into consideration. And that's kind of where Red Hat kind of tries to address with the OpenShift platform. Firstly, how many of you actually heard of OpenShift? Okay, so most of you guys have heard of OpenShift. That's good. I'm gonna just move this a bit, right? I just wanted to address a little bit on, in my opinion, the biggest value proposition that we have as a platform, and that's the security, right? If you all haven't read this, I think it's an important document that every engineer who deals with containers should read. There's a white paper, if you do a Google search for the 10 layers of container security, right? It's actually a very important and very well-written white paper on the security considerations needed for any containerized application deployment. Everything from the operating system layer to the application transport layer, right? And the application service layer. And what you need to take into account to actually design the security parameters around it. Yeah. Ultimately, what we provide is everything from application security down to the platform, down to actually detection and remediation of issues, right? And that's the real value prop of OpenShift in many of our enterprise use cases. Of course, Ascend was one example of a use case, but it was not the only example. Plenty of customers today use OpenShift across the board. You might be using it in your enterprise as well. But yeah, right? I'm going to stop here for a little bit and open the floor, right? So I've got a fair bit of experience in Red Hat over the past 10 years. What are the burning questions that you guys have about Red Hat? I'm willing to take that question. Anything. No holds barred. Q&A. Or is it silence? No questions? Okay. Yeah, right. For costing.
Okay, sorry. So basically, I'm just curious about how do you kind of like manage the costs for each of the like multi-clouds, including like the ingress, egress, or like usage itself for each of the like infrastructure resources. That's it.
That's a very good question, right? That goes into the conversation on cloud operating models, right? As a product, we don't address that, right? With OpenShift, we don't address that as from a product perspective. What we have done though, if you have seen on LinkedIn or followed Red Hat on LinkedIn, one of my colleagues in Singapore and another colleague in Australia has actually written a book called Cost Management and Cloud Operating Models, right? That book covers that on how do you actually manage costing across multiple cloud providers, but not just cost, but also from a technology footprint perspective, right? The other thing that we have done is to partner with IBM right? As you know, IBM kind of owns Red Hat today, or they own Red Hat today, but they do some of the cost management aspects through some of their solutions, right? The multi-cloud management solutions. Yeah. So they do that at that. I hope I answered the question, right?
Yeah.
But read the book. The book I think can be downloaded on Kindle and stuff like that as well. Any other questions? Good. I knew that was coming. Okay.
So just to repeat myself, what comments do you have on Red Hat move to limit the code and number model as opposed to maybe sort of in Terraform recently also did something similar by changing the license model.
Okay, so Terraform did something very different to what Red Hat did, right? Terraform actually closed source. That's very different. Today, Red Hat is still 100% an open source company. No holds barred, right? Let me clarify what we did, right? You all know CentOS, right? How many of you all use CentOS? Okay, you all should move to RHEL, but anyway, that's a different conversation. Okay, what we have done in terms of RHEL, we have been actually shipping the RHEL source code completely open, right, in the past. There was actually no need for us to do it based on GPL, right? Based on GPL, customers who purchase Red Hat subscriptions and Red Hat products need to have access to the source code, right? We didn't need to ship it to you, right? What happened when we shipped it to you? We had a lot of friendly derivatives, right? And people who started reselling versions of downstream from RHEL or from Red Hat Enterprise Linux as their own products, with limited contribution back to the open source community, right? In my opinion, what we did today is now forcing those. This is my strictly my opinion, right? What we've done is to actually kind of force these guys, right, to now contribute that component to straight, right? We don't make it easy for them, right? And that's something that they've publicly said. But now they invest in engineers. So they have invested $10 million to actually help the development of this environment. Straight, right? More investment into the community. Red Hat is still giving out source code for free via our paid products. Anyone who's a registered partner or customer of Red Hat has access to source code. There's no change there. And we can never change that because that's our commitment to the open source community, right? We will never change it. That's what I'm saying. I hope I answered that question or the add-on question there, right? If you want a better answer or more complete answer, right? This guy called Gunnar Helgesen, right? He has actually given an interviews on YouTube. It's a fantastic interview for 10 minutes, 15 minutes, right? Well worth your time to watch it, right? He's our GM for Red Hat Enterprise Linux, and he has been a Red Hat for a long, long time, right? One thing I'd like to dispel completely, this has nothing to do with IBM, right? There's nothing to do with IBM, acquiring us. Right? I think we were very generous in the past. Right now, we want to make sure that we focus our ability to deliver for our customers and our partners. Okay. Yeah. Any other? Go ahead.
Competition process,
Here's my boss method. In fact, quite a few of my direct bosses are now in SUSE, right? But what's SUSE again? What's SUSE again?
and about Ranjan.
Okay. SUSE's market share, I mean, I don't want to disparage them. I think SUSE is a great company. I think their product is great. I used to use SUSE before I joined Red Hat. My ex-boss would always tell my colleagues that, before I joined Red Hat, it was all the while using OpenSUSE, right? Yes, for a couple of years, because Fedora kind of pissed me off at one point. But that's it. There's a market for 2 Linux distributions. There's a market for 3 distributions. I think a healthy SUSE is important, right? It keeps Red Hat honest, right? And it's for the community, right? To me, it's good, right? With DP leading the help. DP left Red Hat in 2021, was it? 2022, right? SUSE approaching the CEO. Doesn't that validate Red Hat to be a good company? And DP got a team. In fact, the guy who hired me into Red Hat is now the APAC general manager as well, right? Joseph Garcia, Frank Feldman, who was my direct or indirect boss over the last few years, has joined as the chief strategic officer as well, right? So a lot of people from APAC are now leading SUSE, which means that APAC Red Hat actually produces a lot of very good people. That SUSE now recognizes, right? But that's it. I think it's good for the community, someone with an open source pedigree who understands open source, right? And I think that's something that SUSE lacks. And it's not by design, it's just because of their the various acquisitions that they have been through, right? With private equity firms and stuff like that, in my opinion. But yeah, I think it's good. I think it's good that these guys are now hitting the ship there. Hopefully they are successful. I don't believe personally that they will eat significantly the Red Hat market share. I think they will have their own space. Right? Once again, I think it's good for the community. I don't think a single distribution or a single player in any one industry competition zones. Okay, 5 minutes. Any question? Go ahead. Hello.
So I'm just curious because you're working in the community, right? Do you think like people in Red Hat have time to kind of like contribute back to the community? Like maybe, yeah, I have like some friends that actually from Red Hat and also like contributing in Kubernetes in general. But I'm just curious if there's like dedicated time or something like that that being allowed for each of like employees of the works.
It's the answer to the question. So let me repeat the question to make sure that I got it correct. You're asking as an employee, you have time to contribute back towards the community completely. So yes, yeah, it's your choice. If you want to, you can do it. There's no restriction that's based on us to say that, hey, look, you must, you cannot contribute to the community, or you must do it under a specific license or whatever. No. So if you want to choose, we encourage like people to actually contribute code to specific projects or even to projects of their choice, not even relating to anything that Red Hat is doing, right? We actually encourage that from if you're interested, right? Or you can contribute to the community in different ways. Some people write videos. I mean, you can see over the last, I think, 5-6 years, there's been an explosion of Red Hatters contributing technology articles, videos, blog posts, articles on LinkedIn, architecture designs in various forms, right? And I think that is something that we will continue for sure, right? It's not just about the code, but a lot of other things as well. I'll say that.
Thank you.
Any other question? No? No question? Okay, if there's no question, then I will probably hand over to the next speaker, I think for my 5, right? Yeah. Okay, thank you very much.
Thank you, Sivaram. Thank you very much.
Davis? Yeah, thank you.
Your language. Yeah, I also.
Oh, thanks.
Working in the
So sorry. Sorry, Zoom people. Just state the most exciting stuff. Yeah. Anyway, how do we enable NetOps and DevOps to coexist to bridge the divide between the big IP world, which is very traditional data center stuff, and the emerging Kubernetes world? Now, in a nutshell, not sharing too much because I only got 20 minutes with you guys, is that there are two technologies that are free of charge. There's no money. If you're a customer from Nginx Enterprise, which is Nginx Plus, and our big IP customer. Container egress service and egress link custom resource. So these are two the high level components that you can install for free inside Kubernetes to be configuring something that's outside. I'll give you a flow diagram later on, okay? Next slide, please.
That's a little
Same.
my changes.
Too fast.
It's a bit delay.
Okay, so I'm gonna kind of stand here for a while. Okay, so this is the blue shaded is where your Kubernetes is. It can be OpenShift, it can be Kubernetes, it can be GKE, whatever that you want to use. And step one, you have your app dev or developers deploy the applications. You know your private registry, your open registry, you can just deploy your application. Now this is where the DevOps portion come in. And the DevOps will manage all your ingress resource using the Kubernetes ingress API that we know is going to be hopefully superseded by Gateway API. But right now, it's just ingress resources. And this one we know, if you take the exam CKD, you will be doing that every day. And next, the DevOps are enhanced in its role in that you can use custom resources, restrictive set of what you can configure outside of your Kubernetes cluster to configure a listener IP or a virtual IP in, for example, a big IP product that is situated outside of the edge of Kubernetes. And you can do a readiness probe. You can also do what's the host name. And basically, the external load balancer in this case will be probing for the health of the ingress controller from Nginx. So that is the marriage that we are talking about. And the beautiful thing about it is that because of the ingress link custom resource, you do not need to call Mike and Daryl to wake up to say, can you please give me a listener IP outside of the edge of the Kubernetes so traffic from external can finally come into my Kubernetes cluster. You can use ingress link resource for that. Now, how do I expose the configuration and orchestrate whatever that I want to do inside a big IP over here? It is through the container egress service. Okay, and that will be the next portion where JY and Francis, the security person, he or she will just focus on big IP over here. You'll be able to see the health status to, sort of do a health check to say, all good from my side, what's wrong inside your cluster, right? Is your ingress is wrong or whatnot? And I can also layer on GSLB, DNS, Active Data Center, anti-DDoS layer 2, layer 7, API security if you want to, and of course, our web application firewall, which I've been doing for many, many years. So that is how we do the marriage between the NetSecOps and the DevOps. Now, the last point is that because CRD is a very restricted set of schema, you can't do a lot of it actually because it's an extension for Kubernetes, right? How about if I want to fully configure an external service to all the services that I can think of, all the parameters? This is where you can put in a flat file, like a JSON file, that will be consumed by our big IP REST API endpoint to configure whatever you need to configure. And I call this guy an enlightened NetOps. I hope it's me, okay? That I know network enough, and then I know YAML enough to be in the Kubernetes cluster to configure what's outside of the big IP. So another beautiful thing about it is that I do not even need to know the existence of big IP. I only see my YAML file. That is the beauty of container ingress controller and ingress link. Now, some colleague asked me this question, since I'm representing Nginx today, other days I represent F5. What if I don't like big IP F5? Because I'm not a network person like you, Davis. Can I have other external load balancer? The answer is yes.
You can use Nginx Plus, external load balancer, and it will work the same way as you would to Big IP, because we have a new project called Nginx Load Balancer for Kubernetes, NLK. It's also open source. Next slide, please. Okay, so I don't know if you want to scan this, but the slides will be given to you. This is a OpenShift cluster deployment with F5 and container ingress service done by our very dear product manager for container ingress service. Now, container ingress service is somewhat open source, it's free of charge, but we have a team developing it. And that's our love for the open source community. Of course, we also develop Nginx open source as well. We didn't stop any support for it. We do have 1 or 2 engineers dedicated to Nginx open source, not just a paid version. Okay, so you will be seeing how does CIS work, okay, with this link over here. And of course, the latest video is about managing multiple OCD clusters with different versions, with just 1 pair of big IP and 1 set of container ingress service. It's actually a deployment, a pod deployment, if you think about it. Okay, next slide. Now, remember Francis? Okay, he looks something like that. Security is my KPI. So how secure can a Kubernetes cluster be? Of course, you can talk about service mesh. Of course, you can talk about ingress controller. Next slide, sorry. Yeah. And I personally has, okay, follow some guide and I recorded some videos. If you're interested, please use your phone again to record all these security use cases that you can turn on in the ingress controller to satisfy Francis' requirements about can we have more granular security controls in the ingress controller. Okay, next slide. Now, in summary, my last 2 slides is that F5 and Nginx today in this user group is trying to tell you, don't be afraid to adopt microservices like Kubernetes, which is the mission of Kubernetes user group, to adopt microservices without a fear for the complexity with less anxiety. F5 Nginx is unifying the application services that is needed outside of the Kubernetes cluster and as well as inside of the Kubernetes cluster. Okay, next slide, please. All right, talking about security is my last slide. Okay, let me do a bit of selling here. If you're interested in specific API security with OWASP Top 10 2023, and you are very interested to find out how do I mitigate third-party API risk, today you can tell me I have an egress gateway that says only approve FQDNs my application can call upon, you know, like a forward proxy. But what if the response packet to us is actually malicious? Visa, MasterCard, Grab, they also can be compromised, right? So this is your third-party risk. This is exactly number 10 of the OWASP Top 10 2023 on unsafe consumption of APIs. So this time I really hope you get your phone out and register yourself with our OWASP in 2 weeks' time. It's in our office in Suntec. I hope to see you there. Register and then come and hear. We have demos definitely to show you how, as a full proxy company with F5 and Nginx, we'll be able to protect you from third-party API risk. I'm going to stand here for 10 seconds while you do the scanning, and that will be all for my presentation. Thank you very much. Any questions? I have people behind to answer. Yeah. Any question about Nginx? OpenShift, don't ask me. But we are certified operator in OpenShift, so I installed before. Yeah.
What is F5 expecting out of the acquisition of Nginx?
Should I answer or should you answer? Okay, so F5 is a very, very old company. We are trying to be a software company and we made it just last year. And we can say that we are a software company today. And with the Nginx acquisition, we want to bring our enterprise-grade application services into the Kubernetes cluster. Therefore, the linkage between ingress link and container ingress services. Now, we want to marry people like me, the DevOps, and the DevOps together. And to be honest, a lot of my customers are driving towards microservices. I do government, by the way, for military. and they are also looking at OpenShift most of the time. And Nginx is always something that is part of the solution that we are doing. So we hope to earn more money with Nginx, but at the same time, we want to contribute to the microservices world.
I would add just the fact that this acquisition gives F5, I would say, more legitimacy in the sense that we contribute to the community. So you, as I said earlier, Nginx open source is maintained, there is engineering team supporting it, but on top of that, there are also all the projects open source that we contribute to. The ingress controller, for instance, is one support, and it's also like CNCF. We are, like David said, the Kubernetes API is one of them as well. We contribute to it. And there are also other things. So as you can see, there are two paths that we follow. One for the enterprise and other for modern, but also the open source one.
Any technical questions? How to install? Does it fail? Yeah, sometimes it fails. Anyone from here? If not, then I will just take my seat. Yes, sir.
Thank you. So I think I saw before like the big IP is available like in GKE, for example, like in the Google Marketplace, right?
Yeah.
But what are aspirations for the use cases? For example, like the company use the private cloud, and yeah, how to like benefit the API and other things.
You mean installing the IP in the private cloud?
Yeah.
Okay, so we have certain deployment model. If it's hardware-based, which means that it could be in a bank or e-commerce that you need the raw power of the SSL chips that we have inside our DDoS application. You can also go into virtual machine, QCOW, VHD. What's the EXI machine? What's the OVA? Yes, then you can install. These are 3 flavors into virtual machines that's supported by a hypervisor. And another one is today, currently, we don't really run F5 as a container. It's soon coming in. So we rely on Nginx as our application services in Kubernetes as a container. So absolutely flexible data center space, private cloud. Anybody know F5 here? You? Only you? Yeah. The question is F5 under OpenShift? Okay, so OpenShift is a platform that is separate from us. They can be your Kubernetes workload platform. You can use the operator hub to install an ingress controller, edit a YAML file within the GUI space. But again, the whole presentation today is about anything that's outside of the OCP, the OpenShift cluster, right? So that is where we are playing. We are playing externally, and we are playing inside the Kubernetes cluster. So we are different from OpenShift, but we are having a collaboration here. Okay. Okay, my colleague want to add something.
Just want to add one thing that F5 is actually from beginning until now is application service company. Like F5 may be like load balancer. That's the most common thing, and that's application services. Web security, access, all those application security. So that's why we complement the OCP. Like OCP is platform, but container Kubernetes container orchestration. Then we add that application services either inside or outside Kubernetes cluster. Yeah.
This application or it's a device. So just we know that LFI is a load balancer. That's how we know. So what I done is the network device. Is a device appliance, or we can install the application the voice also.
So F5 is application services that can be deployed flexibly. We have the hardware, which is the old days, like the appliance, the chassis space, whatever. And we also have the virtual edition, the one that Davis mentioned. Yeah, the OVA, the AVM, the GKE, etc. So that's the virtual, and the virtual can live in either private cloud or in the public cloud. So yeah, it's a separate deployment. If the big IP, I mean the old F5, but engineers can live as that's why the engineers live in the like a VM from the beginning, right? And can live inside or outside Kubernetes, depending on some of the like the team structures, technology-wise, closeness, and we give the option. So that's why when we acquire engineers, actually we also want to bring application services that we were well known of to the DevOps world, while you guys can focus on the application development and the DevOps team. And rest assured that application services, the same enterprise grade in the IT or the APAC world, comes to you also in a very automated, very easy way. You don't need to understand detail about it. Okay, you can automate it. You can even put it as IC, for example, as a code for that purpose, the application service. Cool. Welcome.
Okay, that's it. We'll stop due to time and invite the next speaker. Any questions you can ask us, we are just around the corner. Thank you very much.
Thank you very much for the insightful session. Now I would like to invite Sai for
Presentation, right? I would suggest you do a role play.
I'm not the person. Me another person will play.
Yeah.
Hi, can we please unmute? Thank you.
Okay. So with that, the way we build applications fundamentally change. If you take a look at these are the a few keywords highlights from monolithic to microservices, on premises to the cloud, instead of building applications and on running on VMs and building on Kubernetes. And not only the technology, the way we work, the culture of the organizations change as well, from large teams to the agile teams, right? So when we move from monolithic to microservices architectures, either running on Kubernetes or other container orchestration space, what are the challenges that we face? These are the challenges that we face. So the applications need to find and talk to each other. So which is services discovery. How do we talk to each other? And what about how do we secure the applications to applications communication? And then what about if you heard of like the 10 fallacies of distributed computing? I'm a network engineer, so network is not reliable, right? So how do we manage the transient failure? Sometimes network it's just a flip, and then but the microservices, when one microservices talk to another microservices, they can't communicate. And so how do we handle those transient failures? And what about if we take a look at these microservices, how do we control the microservices? Let's say example, blue, green, red, black, canary deployments, dark launch, all of these techniques. These are the challenges that started to face. So this is a sample microservices that I copied from this Google Cloud Platform. So then when we move from monolithic to microservices today, I'm going to focus from the application networking perspective. So that communication among all of the microservices become an important design decisions when we move from monolithic to microservices. And these are the challenges that I talk about: service discovery, load balancing, and what about resiliency features like circuit breaking, timeout, and retries, and what about observability and all these. So yep, here application teams, developers, right, build their microservices using their own respective programming languages. And then how do they do those, like the security? Let's say some of this microservice and this microservice want to talk to each other and secure. How do we do that? They even pick and choose their own application-specific libraries and embed it into the microservice. And what about logging and monitoring, tracing? And they're going to use, let's say, example, pick and choose the specific language and embed it into the microservices. Right. So what's going to happen? So the moment the microservices start to grow, and what if that application specific libraries has some issues? Let's say some bugs or CVE. What do we need to? How do we need to fix? So we need to restart the whole applications. So developers are best spend time writing code for the business logic that will differentiate your business value. So these concerns are not a developer concern. These are the infrastructure concern. So how do we solve that? We're going to abstract that logic, like I talk about connectivity, security, observability, reliability into another layer. And then which is in this case, we're going to use called application layer proxy, called Envoy proxy. I'm going to talk about that today in the Istio context about service mesh implementations. But this is how we're going to solve that issues. But in the Kubernetes context, those infrastructure concerns are going to run alongside with your microservices as a sidecar container. Right? So let's say if you have 10,000 of the microservices, how do you configure all of these sidecar containers? So we need some sort of like a control plane. So when I take a look at, when I started to see the first time, it reminds me of my network engineering days, I set up a lot of wireless devices. In the wireless access point, there are two different types of wireless access point. One is, before the cloud, Meraki and stuff, right? So one is around autonomous access point, and another one is lightweight. Autonomous access point is we have to use the the console cable with the laptop, and I have to plug it in the wireless device, and I have to configure it manually. Let's see, if you think about the Singapore Polytechnic, they have thousands of access points, and I can't configure one by one, right? So then there is this wireless controller comes in, WLC, and I can just configure wireless LAN controller, and then that controller gonna configure all of the wireless access points from the one single place. That is the analogy that that I understand when I see this for the first time. So all of the platform engineers, SREs, and DevOps engineers just need to communicate with the service mesh control plane, which is a software, and then it will configure and drive the behavior of all of this sidecar proxy. And then this application, microservices application, just remains the same. So this is the architecture. So yeah, every technology is great until that we have to know what are the business drivers. This isn't an exhaustive list. This is one of the major business drivers for adopting service mesh. In this case, I'm talking about the Istio in this context. There are a lot of service mesh implementation out there, like Istio, Kumar, Console, and there are many others. So number one is around security. Another one is around resiliency that I talk about, circuit breaking, timeouts and retries. Another one is observability. And then the last one is around traffic management, like how do we do A/B testing, canary, dot launch of all of those microservices. These are the business drivers for adopting the Istio. And so I try to come up with this diagram when I try to explain to one of my colleagues, which is an account executive from the non-technical background. So life before service mesh and life after service mesh. Right? So developers write a business logic for the microservice applications. What do they need to do is they're going to be using different programming languages. So multiple frameworks they're going to use for security logic, traffic management logic, observability logic, and resilience logic. If you remember about those Netflix days, that they have this Eureka and Citrix and all these, but that is available for the Java, right? And as a result of that, poor developer experience, and they have to use multiple frameworks and hundreds of menu steps. And what we do is we abstracted that layer. One is developer just focus on the business logic, writing on the that will differentiate your business values. And the service mesh, we call it these logics, and hand it over to proxy layer, which is in service mesh context sidecar, managed by the service mesh, running alongside as a sidecar. So this is life before service mesh and life after service mesh. If you don't remember anything today, this is the summary. This is good enough for today. So again, Istio is one of the service mesh implementations out there today. So Istio leverage sidecar proxy, which is, we call it data plane, as an Envoy proxy, which is open sourced by Lyft. And these are the companies that adopting Envoy service mesh as the data plane. So Istio was launched around 2017. It's an open source project where Google, IBM, and Lyft, and then donated to CNCF around 2012, and now already graduated, like I think 2 months ago, Istio graduated from the CNCF. Yeah, so this is the beautiful representation of the diagrams that I talk about, Istio control plane. And then you have the, this is your pod, right? Every service is called as a container. Then you have that Envoy proxy, the sidecar data plane running alongside with your applications. This we call the data plane. So before service mesh, before the sidecar, the application talk to each other directly. Now with the sidecar, the application will talk to the sidecar, its own sidecar, and the sidecar talk to the service B, another sidecar, and it will talk to this service B. So yeah, you may have a questions. If you have 10,000 microservices, you need a 10,000 sidecars. So that will cost a lot of money and CPU memory, right? So you got sidecar. So but as a side note, last year, 2012, I used to work for Solo. Solo and Google worked together and created this architecture called ambient mesh, which is a side-carless architecture. But I kind of covered this today. Maybe I will talk about in the next session also. So that is around service mesh implementation to achieve the service mesh benefits without running sidecar for every applications. So I think I'm gonna do a little bit of demo here instead of just talking and stuff. So in my, oh, sorry, I don't know how to do this. All right. Okay, in these clusters, well, that's fine. Maybe I will shout. I have Kubernetes clusters up and running. So what I'm gonna do is I'm gonna install Istio. So what do I need to do is I already have the I already downloaded the Istio kettle, something like the kubectl that you need to use kubectl to communicate with Kubernetes. So Istio, you need to download the Istio kettle to communicate with Istio control plane. So okay. It's better? Yeah. Cool. Okay. So when I just need to run one command, Istio kettle install. I'm gonna use this profile demo. If I monitor the what will install is it will install 3 components. One is the Istio-D, which is a control plane. Another 2 components is called ingress gateway to handle the north-south traffic from internet, and an egress gateway to go to the outside of the from the cluster. These are the when we install Istio, these are 3 components that installed. So after that, how behind the scene, what it done is it actually extend the Kubernetes, right, using CRD. So if we take a look at here, so these are the CRD that installed, and we can leverage this CRD to drive security, networking, observability, and some other stuff. So how can we take a look at this? If you take a look at here, Istio networking. So these are the CRDs we can leverage, like the gateways and envoy filter, destination rules, and whatnot. The next step that what I'm gonna do is I'm gonna install some of the add-ons. So what are the add-ons? The add-ons are like for your observability stuff, like Prometheus, Grafana, Kiali, Jaeger, and stuff. But this is Istio. When we download Istio, it comes out of the box for some of the manifests for all of these the add-ons, but these shouldn't be used in the productions, and you should use your own fine-tune the environment. So now I install the add-ons like Jaeger, Kiali, Prometheus right now, but I don't have any microservices up and running right now, so that you will not see these components will be not really useful. The next step I'm gonna do is I'm gonna install some of the microservices, like a sample microservices here. I'm gonna install 4 microservices. One is a web API representing as a front end applications, and then it will talk to the recommendation microservice, and then it will talk to the purchase history microservices. And then after that, what I'm gonna do is I'm gonna set up ingress gateway so that the internet from the traffic from the internet can come in and to hit the Istio ingress gateway and access to that web API microservices. That's the first step. So this is just, you can even use the Kubernetes ingress, but now Kubernetes ingress is not really, I mean, it's gonna deprecate soon, right? And it will replace with the gateway API, but it still support the gateway API as well. So now I have my add-ons up and running, but my add-ons are not really useful at the moment. So what I'm gonna do is I'm gonna install, create some of the microservices, sample microservices. So I run sample microservices now in this Istio in action namespace. I have 4 microservices. So right now I didn't include all of these in this service mesh. That's why I only have 1/1, which is my business logic is just up and running right now. There's no sidecar at the moment. So I'm gonna set up any some environment variables so that I can access it in an easy way. So if you take a look at here, Istio have 3 components, right? When I install Istio D, which is a control plane, ingress, and egress gateway. So I install I set up the Meta LB on my laptop, so I have my ingress gateway acting at a load balancer, but this is a simulator, so that's why I use the Meta LB in this case. So to be able to accept the traffic from the outside, we need 2 components. One is, as I mentioned earlier, Istio CRD Istio have a lot of CRD, the gateways, virtual service and stuff. So first we need to configure the gateway CRD. So what gateway CRD does is it will listen. That's it. It didn't do anything. So it's gonna listen on the certain port to accept the traffic. And then the next concept that we need to know is called virtual service. So virtual service, in short, what it does is it's gonna route. So let's take a look at it. Yeah. So if we take a look at this manifest, which is a gateway CRD, that I'm gonna select the gateway CRD for Istio ingress gateway, because this is my Istio ingress gateway port labels, and then I'm gonna listen on port 80. Protocol is HTTP, and then I give it a name called Istio in actions. So you can have multiple gateways in your environment. Let's say, example, some of the customers use, let's say, this gateway is for the internet traffic external. This gateway is for the partner. Let's say, example, you are a bank, you have a lot of partners traffic, so you have a certain gateway. Another gateway can be for security and compliance, for example, for whatever reason. So you can have the multiple gateways. So all you need to do is you just make sure that you just configure the right selectors for the right gateway. So right now, what I'm gonna do is I'm gonna create this gateway manifest. So if I take a look at the gateway manifest, I can use this command called Istio proxy config listener, and then so I can start to see that I have the gateway listening on 8080. So I'm gonna route. But again, this is the important concept that we need to understand. Configuring gateway is not enough in Istio, so we have to configure the route. So if we take a look at the routes here, I haven't configured the routes yet. Now we can see that the Istio ingress gateway is listening 8080, but it doesn't know where to go. So that's why you can see the 404. So right now, what I'm going to do is I'm going to configure the virtual service. Before I configure the virtual service, let's take a look at what is the manifest looks like. So, yep, again, this is a virtual service CRD. I'm going to listen on istio-inaction.io, and this is a gateway that I map, that gateway that I configure with the virtual service. I'm going to route the traffic to web API microservice, web api.istio-inaction.service.cluster.local. Because my web API microservice is running on the istio-inaction namespace. So most of the time, we made this part wrong. So because let's say your microservice is running on particular namespace, and then but you configure it, the namespace like maybe default or something, so it won't work. So make sure that this is correct. Now, the moment after I configure that virtual service and I check my route setup of the Istio, now I can see that instead of 404, now it knows how to go to the web API.istio-inactions. Let's test. This I'm simulating that, like I'm accessing that microservices web API.microservices web API microservice from internet. So if you take a look at it here, I can be able to access to my web API, and then web API is calling to another microservices called recommendations, and then it calls to another microservices called purchase history. So this is how we set up to accept the ingress gateway. But still, this is HTTP. But how do we secure the HTTPS? So again, we can go to ingress gateway. We can secure that our ingress gateway with HTTPS here. So here I would like to take a moment and I will explain a little bit about that. When it comes to the Kubernetes, I came from the traditional data center background, networking. When we look at the security perspective of data center, it's a castle and moat architecture. What do I mean is that you have your data center is got with your ingress, the perimeter firewall, right? So the moment your firewall is passed, everything is open. Well, I mean, you can say that you have this, you have the VLAN configure, you have the Cisco access list configure and stuff, right? But I mean, those data centers is a very static, didn't really change. But in the container world, in the microservices world, it's very dynamic. What do I mean by that is the moment you delete the container, the moment it comes back, it's a different IP address. So we can't rely on the IP address anymore. That's one. So, so traditional day, we take the IP address as an identity. Based on that, we define the security policy, right? In a container world, it's a different game. So if we take a look at Kubernetes, is following the traditional security architecture. You got your ingress layer with the HTTPS. The moment you pass that HTTPS, your ingress, all of your Kubernetes pods can talk to each other. Yeah, well, you can use the network policy in the Kubernetes to secure, but it's only layer 3 and layer 4. What about if you want to do the security for layer 7? How do we achieve that? So, and what about we want to allow this microservice that can talk to this microservices only to setting based on the like HTTP headers and whatnot. How do we achieve that? We call it zero trust. So one of the use cases and one of the business drivers for adopting service mesh is for this zero trust MTLS. So I'm gonna skip that security of the ingress gateway. I'm gonna go at the this application with the service mesh. Right. Okay. So how do we enable the service mesh? I mean, adding those applications to the service mesh is you just need to enable the labels. I mean, there are two different methods. One is the automatic sidecar injection, and one is manual injections. In this case, I just need to label that my microservices are running on istio-inaction, so I just label the namespace istio-injection enable. So, but labeling that namespace does not inject microservices. Still port is 1/1. So that is one of the reasons. And when we introduce Istio service mesh, we need to roll out, restart the microservices. So you can see that it is, I'm gonna do watch. So now it is injecting the sidecar. So you have your business logic, which is a web API, and you have an Envoy proxy. So let's say if you have microservices, you need to restart your microservices to enable this service mesh. So with this Envoy proxy now sidecar running alongside your microservices, a lot of things you can achieve. That is a layer 7 proxy, and it generates a lot of traffic, a connection per request, total number of connections, and latency and whatnot. And then and by leveraging all of these Istio add-on, you can start to look at from the, like, let's say example Kiali example, and you can see how the microservices are talking to each other. That is the immediate gain that you get when you enable the microservice, Istio. So right now, I only have 5 minutes, so I'm gonna skip this MTLS. So MTLS is like this Istio, every microservice is gonna have the sidecar now. That sidecar represent your identity. So leverage the technology is called SPIFFE. SPIFFE stands for Secure Production Identity Framework for Everyone. So Istio D become a certificate authority, which is your root CA out of the box. And then that's every sidecar gonna have the certificates. So that certificate represent your identity. So the moment you have your identity, you can start to define the authentication and authorization policy. And then that certificates is automatically renewed. Say that certificate have like 24 hours, and Istio D always renew every 12 hours. So when enabling the micro MTLS and Istio have two modes. One is the strict modes, and one is the permissive mode. Permissive mode means which is easier to onboard. Let's say you have your microservice up and running. If you are by default is permissive mode, that means you have your Istio right now. Web API is running with its sidecar. The rest are not. So, but they still can talk to each other. But the moment you enable the MTLS mode as a strict mode, so if you don't have the Istio injected for your microservices, they cannot communicate each other anymore. So that restrict the MTLS connection. So I think eventually this is a workshop that I used to run. It takes about 2 hours plus, but now I only have 30 minutes. So I think that's it for today for me. So to summarize, MTLS that I talk about, this is a thing that I mentioned earlier. Kubernetes, by default, Kubernetes security posture is traditional castle and architecture, because I came from the networking background. It resonates me. I always map back to how I've done in the on-prem traditional space. One is on the zero trust security, where every microservice is going to have a sidecar represent an identity, and then you can enforce your security policy to achieve the zero trust. Yeah, again, you don't need to renew the certificates manually. Automation require Istio to do that. But in the production environment, you can leverage like a cert manager or HashiCorp Vault to represent a CA and to do all your certificate management and certificate lifecycle management. So a few things some things to think about. Let's say you have your Kubernetes cluster running on multiple cloud providers. And let's say if your Kubernetes cluster is down in the one cloud provider, how are you going to route the traffic to another cloud providers? These are the things that we can, some things to think about. So how do we achieve the MTLS across, let's say example, you have within a one cloud provider, within like maybe multiple different regions, you have the Kubernetes clusters running on running your business logic. How do we route the traffic? And what about the upgrading of Kubernetes release every 6 months, right? And then Istio, I think, every 3 months. How do we keep up with the upgrade, right? So all of these things, and there are many things that you can think about to how do we scale when we run the Kubernetes as well as the Istio. And yeah, that's it for today. And one last joke. Let's we have one of the I talked with my sales counterparts, and if you have your microservices, you say some of the whole bank running on one Kubernetes cluster, you did the application modernization, but you are doing the monolithic microservices again. Let's say if your Kubernetes cluster down, the whole bank is down. So you may want to think about starting to break it down, your microservices, your Kubernetes cluster to the multiple clusters, maybe for business unit or for products or whatnot. And these are some things that you think about that I want to share. And thank you all very much, and that's it for today. Yeah.
Any questions?
Yeah, I used to work for Solo, which is focusing on the service mesh application networking stuff, and I used to work for a company like Chef, Chef Puppet and some other space. And then I quit Solo and I'm doing on my own called Hello Cloud. Hello Cloud is actually focusing on the education technology startup, I would say. I was born and raised in Burma. So the family moved to Singapore 17 years ago, and I came across, back in the networking days, I created a video tutorials called naming called RHC Technologies in the Burmese language, because I came across it in internet. You can find a lot of technologies in English, but like Burmese is I can't find any Burmese tutorials. So I created the networking tutorials, 300 plus networking tutorials focusing on like BGP, USPF, MPLS, and all this kind of networking stuff. And then I stopped and I moved to the cloud. And then I came across that there's no Burmese content in the cloud native space. So what I did is I started creating Kubernetes, AWS, Istio service mesh in the Burmese language. So that is what Hello Cloud does. To do some sort of like you can think like a social enterprise, just focusing on the Burmese language. Yeah.
To take it over.
Yeah, thank you so much. So before we go to the quizzes game, so we always welcome speakers and sponsors for the upcoming events, right? So we already have a speaker full, so we need more speakers to uh, present in our upcoming events. So if you're willing to contribute as a speaker, so you can contact us directly or directly use things you can register as a speaker and for sponsors. So this is our LinkedIn page. So if you're not registered or if you're not joined with our LinkedIn page, so please, we welcome you to join our LinkedIn page as well. So let's move to our
Yeah, give me a minute, so let me load the quizzes page. So we'll have 10 quizzes and 30 seconds for each question. So first, so we'll be getting this book, and others also will be giving some giveaways. Right? So you can join the quiz game using this QR code. So let me know when you're ready. So quizzes contain the topics we discussed today. Are you guys ready? Yeah, I can see 8 people have joined. I think we have more people here. Yeah, Morley, Mithun, Lucas, Erwin, Asankar. Snowfall, and Long. Okay, we have more. 16. Okay, I'll give you 1 minute more. Anyone have any issues connecting? Okay, so we are going to start. Take care. Okay, the first question in FING next presentation, what was the first anxiety shared as a personal example? So there are 6 answers. So the next question. Security is a team's sport between which 2 personas are mentioned in the next presentation. Okay, next question. What does BITC stand for? in the Nginx presentation. So I can see Jonathan is leading at the moment. Okay, next question. What were the two technologies mentioned as a possibility for DevOps and NetSecOps to collaborate? Who is www? Where it is? Yeah. Okay. Okay, next question. What is the name of the security personnel who seconded identity? Okay. Sixth question, 4 more to go. Where is F5 and Nginx unifying the application services needed? Okay. Next question. F5 is committed to bridge the divide between which two worlds? Okay, next question. What are the ways you can install STU? Okay, Asanka is leading now. Next question. What is the name of the STO sidecar container that is added to your application? Okay, Asanka. Can you raise your hand, Asanka? Okay, next. Last question. STO can make the applications more resilient to failure with which of the following features? Okay, it's in. Right, first, Jason. Yeah, so I would like to invite our sponsors team to handle the gifts. So, Jason. Sorry. Oh, okay. From down. Sorry. Okay, we are giving away for the first 10 winners. Kevin.
Kevin C.
Kevin C.
Kevin C. Win. Okay. Nice gift. Hope you won't have to use it every day.
Next way is, what's your name? YD. Okay, so. Okay, Austin.
Yeah, okay.
Austin. Sean B.U. Yes. Naufal. Murali. Murali Rajgopal. Jonathan. Yap. Jonathan. And top 3. Lucas. Osankar. And the winner will get a book. Jason. Thank you, guys.
Okay, thank you very much, guys. And before you go there is a pizza and some stickers over there. So please help yourself. And before going, can we have one group photo? Can everybody come to the podium over here? It will take 5 minutes. We'll take a group photo. Thank you.
Yeah, at the same time, we would like to thank our sponsors, F5, today's event sponsor, and our long-term sponsors, Google, CloudCasa, JFrog. So because of them only, we are doing this continuously for the event, this event. So we thank everyone who joined today's event, who physically came here, and our Zoom attendees as well. So we'll meet on our next meetup in September, so 19th meetup. So hope you all join again. Thank you.